Hello everyone. In this video, we will learn how to use the HPS ARM to communicate with the FPGA, and then use my first HPS project here that has all the files required for the RTL and the C file to demonstrate the implementation of using 7-segment display on the board, and we will display a running counter generated by the HPS, and it will count seconds, minutes, and hours and display them on the 7-segment. So the first thing we need to do is to run and prepare the FPGA RTL. To do so, I need to run the QPF file here and generate the bridge that connects the FPGA with the ARM processor. So while it's loading, I'm going to run the platform designer tool. This tool is needed to create the bridge between the FPGA and the ARM processor. So I'm going to choose the system on chip system, Qsystem, and open it. Right now it's loading. In this part, I will create parallel input-output peripherals that connect the ARM processor to the 7 segments. So right now I just finished importing the design. The next thing I'm going to do is, as we can see here, we have this bridge for the Cyclone V hard processor system, and we have here the parallel input-output peripherals for the FPGA. That was for the previous project. I don't think we will need this one for now, and I will keep moving, doing this after I just finish. So I will just delete this. I will not need it. So I'll click on remove, and I will, in the IP catalog part, I will create PIO new parallel input-output interface, and I'll click add. And here, since we have 7 segments, so it's going to be like the bit width is 7 bits and the direction is output, and as we can see here, it's going to be the reset value, which means turn off the 7 segment, which is 7F. So that's how we generate 1 1 1 1, like 4 ones and 3 ones for the 7. After I finish, I'll click on finish here. So for me, it generates here the bio. I will rename it here. I'm gonna name it bio x0. All right, and then I will connect the clock for this peripheral to the system clock, and the reset to the reset, and as we can see here, the S1 to the exact location of the H2F LOW, and that's fine because this error we are getting it because it's overlaps. So to eliminate this error, the only thing I need to do is to uncheck the parallel input-output lid and just remove it. Okay. The next thing is to just export this one to the export external connection. Okay, so I'm gonna repeat this procedure for like 5 times since we have 6, 7 segments. So I'm gonna add a new one that's gonna be 7 bits of length, and the direction is output, and this is gonna be 7F, and finish. After that, I will rename it. I'll call it X1, and I'll connect it to the clock and reset, and to the HPS as well. So right now it's overlapping, and we're gonna see like this error 4 times, and we will solve it in the address map because both of them have the same memory address. That's why we are getting this error, but that's fine for now. All right, so 7 output, 7F, and finish, and 7 7F and 7, 7F and finish. All right, so as we can see here, I will rename these values for now, X1, X2, and this is going to be X3, and this is going to be X4, and we only need to add final 7 segments. 7, all right. X5. So I'm going to connect all the clocks to the system by itself. So right now, make sure that to the clock 0. Okay. And this one is going to be connected to clock 0, clock 0, clock 0, and reset, 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 reset. Okay. After that, I will add overlap address to the same one as well. So here's where I get the clock. Okay, and the only is the overlap. So after I finish this, I will export the external connection for each one. So I just all right. Right now, to eliminate this problem, I will go to address map. As we can see here, we have all of this. So I will go to system and assign base addresses. So it assigned to each hexadecimal, 7 segment, sorry, base address with the start and end. And if we go to the system, we can see here each one has its own base address and end address, base address and end address, which is cool. So we are just getting these warnings. The next thing is I will go to the generate and see instantiation. I will need these components to add them to the design. All right, so I'm gonna copy them for now and keep them after we generate the system itself. All right, so copy. Okay. After that, I will generate the HDL, and it's gonna be like the HDL Verilog. I do not need anything for the simulation part, and the path is at the same directory. So I'll click on generate, and as we can see here, save system completed successfully. I will close and it will generate right now the system and update the Quartus files in the background. All right, so I will just wait. So the process is validating. After it finishes validating the system, doing the reading input file. It's gonna take some time based on your machine and how it performs. So I'll stop this for now until it finishes. Okay, so right now we have completed generating the design with some warnings. These warnings are not that important, so we can just ignore them. And I will get this message. This message means we can ignore it because the system will already update all the required files. So just ignore them. And if you go to the files here, you can see all the This is the system file that we have generated by the Q system, and as we can see here, these are the wires output, which are by parallel input output hexadecimal 0, 1, 2, 3, 4 till 5. So I need to go to the golden file and update the values, the outputs of the external. So that was for the lid. I'm gonna comment it and just paste the values that we got on the design, and instead here I will insert hex 0. I don't need this one. I will just copy the right to the rest. Right. Okay, so this is the 1, 2, 3, 4. I just want to make sure that I did it the right way. So if I go to the system, platform designer, just I want to see how much pixels do I have in the design. So as we can see here, I have 0, 1, 2, 3, 4, 5. Okay, let me go to generate, see the template. How many do I have? 0, 1, 2, 3, 4, 5. So the reset, and I will copy them, take them to the Quartus. Just wondering why I didn't get the exact same number. Okay, so I'm just gonna go and take, I'll delete those for now. X 0, X 1, X 2, X 3, X 4, and X 5. Okay, so right now we are in a good shape because we have here like all the outputs for 0, 1, 2, 3, 4, 5. Okay, good. So I'm gonna save these changes here, and these changes I'm gonna save them here and run and compile the design. Now it's gonna take like 10 to 12 minutes to finish it based on the performance of your PC. So I will come back again once it's finished. So as we can see here, it took almost more than 12 minutes to finish the compilation. After that, I will need to regenerate the HPS or 0.c header file and add all the content to it. All right. Right now we have done with it. So if I go to the netlist RTL viewer, we'll generate the design. We can see from here the design have been connected to the 6, 7 segments. This is the first one, the second, third, fourth, fifth, and sixth. All right. So our next part will be regenerate the header file, which is the HPS underscore 0 header. So if we can and open it, it doesn't contain anything about the hexes, and it only contains the from the previous project the lists. To do so, I will go and open the NIOS to command shell, and as we can see it here, this is open the file location and run it as administrator, the 24. So I'm gonna go with NIOS 22.1. Okay, so if I open the file location and run it as administrator, it will open the NIOS shell for me. All right, good. So in this part, I will need to run the following. I will need to run the generate HPS Qsys header underscore file. Once I generate it, it will like regenerate and update the original one. So I just copied this, and if I go to list, I got nothing. So if I see cd mnt, so mn, so it lists all the files that I have in the system32 folder, but I don't want this, and just click and it will paste the entire design, but I don't need all of it. Users, and I will change just the slashes from the backslash to the front slash. All right. Okay, so if I lost the content of it, I can see here the generate hps.th, so I will just run this file. Once I click on enter, it says generate cannot execute, required file not found. That's fine, but that means at least it's updated the header file. So if I open it right now, if I click on make, I think I need to do something with it. So I got all these comments here. So if I go not this order, all right, I will create here the signal and I will run it manually. All right, so it's creating micro file HPS underscore O from the module. If I go to the HPS right now, I can see it's updated. And if I open it right now, as we can see here, it added to us. This is the ports that related to the X5 and X4, X3, X2, X1, and X0. Good, great. So the next thing I need to do is to copy this file and replace it with the exist one that we have here in the HC. I will not need this anymore. I will delete it and I will paste the new one. All right, I've already updated the main.c file to calculate the seconds, minutes, and hours and display them on the 7 segments. So as we can see here, we have defined the addresses for the hexa display, and we created the encoding that counts from 0 to 9, and we updated the HPS underscore 0 header, and this is the equations here. If seconds equal to, we will increase them, and it will count from the minutes till 60 minutes, then it will calculate the hours and the seconds. All right, and then we'll clean up the memory. So to run this program, I need to go to my sys, MS System 2, and run it as administrator or something. Okay, so we are in the shell, and if I write C user download, okay, my first HPS page list, I need to go to CD my FPGA, and inside the HPS system file list everything. I can see here that I have the main.c file, so I'll just make the binary code. So it says no GCC file. That's because I didn't run the I didn't run the embedded patch file. So to do so, CD. I need to go to CD to the C. All right, to the Intel FPGA 20.1. Sorry, 20.1 embedded, and if I list, I need to run the embedded command shell file. All right. So after that, I will go to the my base list, FPGA, and inside it to HPS and list, and then I'll click on make. Okay. So as we can see here, it generates from my first HPS system file, this one, where I can find it here, as we can see. So we have generated the binary file. This file, I will copy it to the flash drive and move it to the Linux system that's already installed in the FPGA, and run it to communicate it with the 7 segment in the FPGA. So to do this process, I will need to go here and find, let me delete this one here, and find the FPGA. So this is my next part of this video. Will show you how to interconnect how to connect the FPGA with the HPS using the SOA file and the binary file that we generated from this design. So that's what we're gonna see in the video that I already prepared in the lab. So after we compile the C, after finished compiling the C program, generate for us my first HPS FPGA. This is the binary code where I'm going to take it and implement it here in the Linux terminal. So right now I have both sides. This is the FPGA side and this is the Linux side. What I'm going to do right now is I'm going to take the binary code. I'll go to download where I have the file, and it's inside my first FPGA base part 2 HPS, and this is the file, binary file that I need. I'm going to copy it and paste it here inside the USB. Okay, so right now I'm going to take the USB and move it to the FPGA board and I will try to run it. So to do so, I need to go to the root and then fdisk/al. Sorry for that. fdisk/al, and as we can see here, it gave me the directory for the SD card. It's in div SD1. So I will mount this to the media file. Div is DE1/media, and I will save it to the USB drive folder. Okay, right now if I go to the same place where the media file folder is, we can see here my first HPS FPGA file. So before I go and implement it, I need to go here and choose the hardware for the FPGA and detect the device, the family device that I'm working on. I don't need this one, and add the SO file. So right now I'm going to implement it to run this code, and the screen will disappear. Alright, and now I will start running the FPGA. As we can see here, start counting, and right now it's 10 seconds, 11 seconds, and I'm gonna wait until it's become 1 minute. So this 27 segments is 4 seconds, and this 27 segments is 4 minutes, and this 27 segment is 4 hours. So after it finishes 60 seconds, it should count 1 minute, and that will be continuing till it become this, until the minute becomes 60, it will turn on to 1 hour, and so on. The reason it started from 6 seconds or 7 seconds because I run the Linux terminal before I run the FPGA. That's why it starts from there. So as we can see here, it's counting 1 minute, and I will leave it till it count 2 minutes, then I will stop. Okay, thank you so much for watching.